Hey YouTube, welcome back. Today we have this problem. This is the second solution for this problem. In the previous solution, we went to go with the recursive function to solve this problem, and we have a time complexity or O of 2 to the power of n. So it was really big, really big time complexity. And right now we will try to improve this solution by like adapting a new solution. Just don't think about this solution anymore at all. So let's read the problem first and try to understand it, and after that let's try to describe how we can finish how can we solve this problem. So problem number 70, climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways you can climb to the top? Basically, if we have 2 steps, there is only 2 ways. One, it's 1 plus 1 step, and we have 2 steps directly. And the 3 here also 3 steps. We can take 1 1 1 or 1 2, like 1 step 2 steps, or 2 steps and 1 step. The way that we can solve this problem, we could in the previous approach that we used recursive functions, and we were calculating the results for every step. Right now, I guess we could improve this solution by creating like a memoize function, like a function that takes memoization. Because if you can see here if you can see like here, like let's take 2 and 3, let's just take 2. Like the number of steps of 2 is built on number step of 1, and number step of 3 is built on the steps of 2. Because if I am going to 3, like let's say that I'm going to from 0 step. If I'm going from 0 step to the 3rd step, okay, and if I'm going from the 0 step to the 2nd step, the thing that you can see here, that if I am the number of from to the 3rd step, I could get from 2 ways. First, I could just go from 0 to 3rd directly, or I can memorize the value of the going from 0 the 0 step to the 2nd step. I can memorize this value and try to go from the 2nd to the 3rd directly. So this way you will be way more beneficial, and maybe we get time complexity of n instead of O2 in power of n. So let's just draw it into the coding. Let's try to think about this one. First of all, I guess I want to create a memo. So basically, let's create a memo const. I will call it a memo array, basically memo, and it will equals a new array, and the array will be equals, I guess, n plus 1, and we will fill it with zeros right now. And maybe we have a recursive function that we're trying to call. So let's just create the function recursive, and this one will take I and will take n. I will be the index of the current step, and n will be the full length of the step, and it will take the memo. So we remember each step that we have passed through, so we will not duplicate ourselves. So we have this memo. We can call the recursive function. We start with a 0 step, and we give it n and memo. And here we have the climb stair recursive. And before going through any recursive functions, something that we say always and always, we should first think about our edge cases. So when this function will stop, if there is no steps, if there is no more steps to go through, so this one, it will be if I, which is the index of the current step that we are in, is bigger than n. Okay, if there is no step that we can go through, so we return 0 here because there is nothing to go through. Or if I is equals to n, that means there is only one step to go, so like we return 1. So right now we have our base cases. Let's just try to see how we can continue this functionality. So we have we have right now to think what should we do next. The thing that comes to mind, if I am in the specific step, I want to know if I is in the memo already, because if I in the memo, I will not call the climb stairs recursive. So I will say if memo of I bigger than 0, because we fill it with 0. If that was the case, I will return memo of I. Okay. So right now we're trying to memoize everything. However, if memo of I doesn't equals 0, or yeah, it's equal 0, that means this step is new to us. We never saw this step before. So the first thing that we do is that we store this step. So we have memo of I, okay, equals. Okay, let's just stop here because that will look quite complicated. What will memo of I equals? Like, let's say that I'm in the third step. I am the second step. What is the second step equals? If you can see here, the second step equals two things, like going one by one or two directly. Okay, and here if you can see is the third step, it equals three ways, going ones or 1 2 or 2 1. So we have two things that we do all the time, like go ones and twos, and try to also try each possible step with each number with them. Like for example, I started with 1 here and I put all ones, and after that I started with 1 again and I say, can I start with 2? Yes, I can start with 2, so let's just do it. And I start with 2, I ask myself, can I add 2 with the 2? No. Can I add 1? Yeah. Okay, let's add it. If you add 4, it will take the same time. It will be the same, but it will be quite complicated. So what should memo equals? Memo equals the climb stair recursive was going first with 1 step, so I plus 1, and I will add the memo, plus going with 2 steps. I know it looks quite complicated. Recursive function is not easy topic. It's not easy topic, so it takes your time. And after that, we return memo. Let's just try to describe what's going on here. So basically, let's just take this in as an example. Oh, no. So, and let's try to take I. So we start here I with 0, and we have our memo array, which will be n plus 1, so it will be 0 0 0. Okay, so what I'm going to say first, let's just try to search through it. So we have here I bigger than n. I'm returning, I'm just trying, let's escape these two base cases. For the first one, let's not skip it. Let's just try. N equals 2. Is I bigger than n? I is 0 and n is 2. No, this is not true. So if I equals n, I is 0 and n is 2. This is not true. So we continue. If memo of I bigger than 0, memo of I is 0. So this is not true. So what we're going to do is that try to climb the stairs, and we do the term stair recursive. We're going with 1 step and going with second step. Let's just take this 1 step first. Okay, we are right now in 1 step. So right now we are in the 1 step. So let's just go this one. We call this again. So in 1 step, when you call the I again, I will equals 1, and everything will be the same. So I'm saying if I bigger than n, this is not true. I equals n, this is not true. if I of memo of I, memo in index of I, in the index of I becomes 0. Oh no, it's 0. So we return. So we call again. Okay, just be aware with me. We call again. Right now we are in the first one. We call again. This is right now a third level of calling. We call again, but the third level have a pretty interesting thing, because I equals 1. When this one we're trying to call it with the left one here, I will equal 3, and 3 it will be because an n. So this one will return 0. So when you try to call this I again, okay, I will equals 1, and we return 1. And when you return 1, you go to the second level, because this will return 1. And when you return 1 with the second level, you save it in the memo. Are you with me here? You save it in the memo. So when you save it in the memo, that will be 1. And when this will be 1, this will return 1 for you. And when you go to the first level of the recursive function, you will find that this one is returning 1 for us, and we're saving it in the memo, so we don't have to try again. So basically, what was the magic is coming that when we try to this 2, so I equals 2 here, and we find that the actually is memo of I, because actually this will be 1. Is bigger than 0. And also the second thing, it's like these two will be true. These two will be true, because like if I put this one first, the memo will call it. If I put this one, the I will call it. So this one will return true also. So when you return true, it will be 1 plus 1. I know it's too complicated, but like, the recursive wasn't never an easy topic to discuss. Sorry guys, it's all the time tough, but just give yourself time. So basically, instead of just calling the function and all the time and just call it everywhere, we call it, and each function we save its value in the memo. So basically, we save each step's value in the memo. So to make sure that we are not calling our function endlessly, or not endlessly too much. So basically the time complexity, instead of being O of 2 in the power of n, it will be O of n only, which is huge. So yeah, that's it. Let's just try to submit the code first. Oh, it didn't work. Why? If memo. Let's submit it right now. Let's see. Oh, it didn't work. Why? Why it didn't work? Why it didn't work? Oh, that's weird. And memo, and I'm returning memo, and we should return something. Voila. And I'm beating 93%. Oh, that's too much. That's good. So yeah, that's it for today's video. I hope my source was quite good. If you like my content, make sure to subscribe and hit the notification bell so never miss a video, guys, and see you in future problems.